Good morning, students. I hope you have seen my previous videos and you have understood the topic upthrust, the characteristics of upthrust, the reason for the upthrust, and the conditions for sinking or floating of the body. Today in this video segment, I am going to explain these few topics: Archimedes principle, applications of Archimedes principle, density of the body, and relative density of the body. So first we'll go for Archimedes principle. So now students, we'll focus on Archimedes principle, which states that when any body is immersed in fluid, partially or completely, it experiences an upthrust which is equal to the weight of the fluid displaced by the body. Now what does it mean? Any body, whichever kind of body, when we are trying to immerse inside the fluid, that is liquid or gases, then a definite kind of opposing force it experiences, which is called upthrust, and which is equal to the weight of that fluid displaced. It means to get inside, the body has to displace some weight of the body, some weight of the fluid, so that it can go inside. So whatever amount of the fluid will be displaced, that much part of the body will go inside. This is the statement of Archimedes principle. Now we'll come for the applications of Archimedes principle. As you can see, I have written 3 applications which are very common and very important. Number 1, submarines. What is submarine? You must be knowing, you have studied in previous classes also. Submarines are the ships which are having blast tanks and which works on the principle of the fish bodies, the bodies of the fishes. When it has to go down, it has to fill the water inside, and when it has to come up, it drains out the water quickly and it comes up. So similarly, it is utilizing the principle of Archimedes. Second, I have written lactometers. Lactometers are also using the principle of Archimedes, and it is helping us to check the purity of the milks. And third, hydrometers, which are used for checking the density of different fluids. So I hope, student, you have understood the Archimedes principle and you have understood their application. Further, we'll go for the density and the relative density of the body. So now we'll understand this new topic, which is actually not new for you. You may have studied in class 7 also, class 8 also, and now in class 9 also. This topic is density. Why I am telling this new? Because along with this, we are going to do few numericals which will be new for you. The topic's density itself defines about 2 things, mass and volume, how they are interrelated. The definition says the mass per unit volume of the body is called density of the body. So density is equal to mass by volume. SI unit of density is kg per meter cube, and CGS unit of density is gram per centimeter cube. I hope it is clear, students. Now, the factors affecting density, if the question comes, then what will you write? The density is directly proportional to the mass of the body. It means if the body's mass increases, then the density of the body will also increase. Whereas if the volume of the body increases, then the density of the body will decrease. It means the density of the body is directly proportional to the mass of the body, whereas it is inversely proportional to the volume of the body. At last, we'll focus on relative density. Now students, we have come to the last topic of today, that is relative density. Density you have understood. Now to understand relative density, what we are relating here, that is important to know. Relative density says the ratio of the substance density. It means density of the substance to the density of the water at 4 degrees Celsius. It means when we are comparing the density of the substance to the density of water, then we get relative density. Now you must be thinking that, sir, why I have not written the SI unit or CGS unit of this particular thing. Some of you may know this also. What is the reason? Because you may have taught, you may have given the lessons that when we are comparing the same quantity, or when we are dividing the same quantity with the same units, in that case it is called unitless. It means when we are dividing the density of substance to the density of water, somehow we are dividing the same unit, so they will cancel out each other and it will have no unit. So relative density, how can we define? It is defined as the ratio of the density of the density of substance to the density of water at 4 degrees Celsius. Along with that, I have written some more formulas so that it will be helpful to you to solve the numerical section. It also relates with the mass of the unit volume of substance to the mass of unit volume of water at 4 degrees Celsius. More, we can write this along with the help of its weight. The relative density is also known as the weight of the body to the weight of the water displaced, which is somehow relating with the Archimedes principle. Further, we can extend this formula, which is known as weight of the body in air divided by weight of the body in air minus weight of the body in water. It means weight of the body in air divided by weight of the body in air minus weight of the body in water. So I hope, student, whatever today I have explained to you, it will be helpful to you to complete your notes, as well as it will be helpful to you to complete your exercises. And I request each and everyone, if you find difficulty in any of the question of the exercise, you can contact me through WhatsApp, you can write in comment box, as you wish. You can ask your problems. You are most welcome for that. So thank you so much and have a good day.